all the way to the end. Jordan, can you guys pass it all the way to the end? Evan, and another one. And Keenan. Thank you.
Why don't you bring your
Andrea, right? Spencer, Tucker, Zach, Michael. Okay. Did I miss anybody? I'll take that as a no. Okay, so questions.
They said I was missing 42 and it's right here.
Okay. Let's talk after class. Okay. Yes. Okay. All of them. That sounds encouraging. Yes.
Is this just on T5 right now?
The homework is from, what was it, 2.5 and 2.6? Number 16? Yeah. 16. We have g of x is equal to, oh, never mind, no equal, plus x times sine of g of x is equal to x squared. So to some extent, this is very much similar to what we did before, in the sense that you can denote g of x with y, and basically it's implicit differentiation in terms of y. So to find g prime of 0, we need to figure out what g prime of x is first. And so if you take derivatives in both sides in terms of x, you'll end up with g prime of x plus sine of g of x plus x times cosine of g of x times g prime of x is equal to 2x. Right? Yeah, this is a semi-weird problem, because g prime of 0 is equal plus sine of g of 0 is equal to 0. So g prime of 0 is equal to negative sine of g of 0. And we have no idea what g of 0 is. Yes. From 2.6? Okay. So let's see. 20. We have x to 2/3 plus y to 2/3 is equal to 4. What is your problem with this? Is how to take the derivative? Is that the difficulty, or? Okay. So what's the derivative of x to 2/3? 2/3 x to negative 1/3 plus what's the derivative of y to 2/3? 2/3 y to negative 1/3 times dy over dx is equal to 0, right? So, short version or long version?
Short.
Dy over dx is equal to the cube root of y over x.
What?
Minus, sorry.
No.
Well, you said short version.
I thought short version, like you're just going to not show the work. You did dy dx by itself.
Well, that's what I did. I not showed the work and I...
Super short.
Okay, first of all, notice that 2/3, you can divide by 2/3 both sides, and that disappears, right? And so you have dy over dx times y to negative 1/3 equals minus x to negative 1/3. So now if you multiply by y to 1/3 both sides, you'll end up with dy over dx is equal to negative y to 1/3 x to negative 1/3.
Oh, wait. You
Yes.
divide it to get it over. I thought you divided it.
I can divide by y to negative 1/3, or I can multiply by y to 1/3. And if you notice, this is nothing else but y over x to a 1/3. So now, dy over dx at the point minus 3 root 3 and 1 is equal to, let's see, the cube root of 1 over 3 square root of 3. Wow. They surely know how to pick them.
You in the book.
This time it's all in the book.
I just got 1 over square root of 3 for the slope. And then I just put that in the y over.
This is the slope.
What?
You can write it as 1 over 3 times the square root of 3 is going to be the cube root of the square root of 3 cubed, which simplifies to 1 over the square root of 3.
Oh.
That's negative though.
Nope. Because there's a minus over here.
Oh.
That cancels with this minus. So y minus 1 equals 1 over the square root of 3 times x plus 3 times the square root of 3. Is this making sense? Or are you still stuck on this from here to here? Well, keep in mind, the cube root of the square root of 3 to the third is the same thing as 3 to the third to the 1/2 all to the 1/3, which is the same thing as 3 to the third to 1/3 all to 1/2. So it's just 3 to 1/3, 1/2. A to the m all to the n is equal to a to the m times n. So it can equal a to the n times m. So it's a to the n all to the m.
No.
It was 3 times the square root of 3.
Oh, okay.
It's 3 times 3 to the half. And if you add it together, it's 3 to 3 halves. Oh yeah, I did. For some reason, it doesn't work. Ah, because it's in the other plug.
Oh, there we go. Sweet. Thank you.
Okay, so what else?
Miley Cyrus.
Review number 24.
This is all from 2.6?
Yeah.
Should I have just started from 2 going to 30?
Yeah.
Okay, 14. Sine of x plus cosine of y is equal to sine of x cosine y. So again, take derivatives both sides. What's the derivative of sine of x? Positive cosine. What's the derivative of cosine of y? Negative sine y dy dx equals. What should we acknowledge on the right hand side? It's a product of two functions, so we need to apply the product rule, right? So it'll be cosine x cosine y minus sine y dy dx times sine x. Yes?
So when you take the derivative of like a function like cosine y, doesn't the y go away?
Again, y is implicitly a function of x.
Okay,
So you have to take the derivative of y as well. Well, just think about...
like I said, the sine of 1 times whatever. I don't know if that's right.
That's wrong.
Oh yeah.
Come back here. We had sine of g of x. When you take the derivative, you end up with cosine of g of x times g prime. Is this clear?
Yeah.
Well, that's exactly the same thing there. It's just that y, if it's harder, if you're finding difficulties remembering to take the derivative of y as well, just write it y of x. When you actually write out the problem, just write y of x, and then hopefully that way you'll remember that it's actually a function of x. Okay, so I'm assuming you can solve for dy over dx here? Or is that a big assumption?
That's an assumption.
Which basically tells me that I should solve it, right? Long version or short version? Okay. So dy over dx equals cosine of x minus cosine of x cosine of y divided by sine of y minus sine of y sine of x. Okay? Move the orange to the right hand side. Move the whatever that color is to the left hand side. Move on. 24.
Yes.
Alright, since I'm doing like half your homework, I might as well actually keep track of what I'm doing, since I shouldn't get, I don't want him to actually grade me, I want him to grade you.
It's okay, you can grade the easy ones.
Okay, so, oh, I don't have a homework sheet. But I do have one in this one. Okay, so which ones have we done? 14, 14, 16, 20, 24. Well, I guess we're starting 24, right? That was the next one. 14, 20, 16. Okay? 24. What is 24 telling us over here?
Find the second root and the square root of that.
That's simple. So what is the derivative on both sides? 1 over 2 times the square root of x plus 1 over 2 times the square root of y dy dx is equal to 0. Right?
Are you opposed to us writing everybody's square root to 1/2? If you want us to write it that way.
No, you can do it to 1/2 if you want. As long as it's positive exponents, that's more. There are two things that I would like you to get used to. I would like you to get used to writing with positive exponents, but also the square roots sometimes actually come into play. And I think I gave you an example a couple of times, right? If I ask you what's 8 to 2/3, you know, it's not as obvious that it's actually equal to 4. So, but if you write it the cube root of 8 squared, or you know, whatever, the cube root of 8 quantity squared or something like that, you can figure out what it is. But you don't necessarily have to. You'll find out at some point later on that it'll come in hand. But okay, so now from here we have to find the second derivative. And as it turns out, the easiest thing to do is to actually solve for dy over dx and then take the derivative. So dy over dx is going to be just minus square root of x over the square root of y. No, wrong. Y over x. Square root of y over square root of x. Which is the same thing as... Should I leave it like this? Or should I write it as a fraction, to square root of a fraction? The idea is from here that you have dy over dx times 1 over 2 times the square root of y is equal to minus 1 over 2 times the square root of x. And if you multiply by 2 times the square root of y both sides, it gets on top. Okay, so now dy or d squared y over dx squared is equal to minus square root of x over 2 times the square root of y minus square root of y over 2 times the square root of x divided by x. And so I'll put in the minus so we make our life a little simpler. So it ends up being 2y minus 2x divided by I guess I don't need the 2. Never mind. So I have y minus x divided by 2x square root of xy. Yes?
I got x to the 1/2 plus y to the 1/2 over 2x to the 3x.
Say that again?
X to the 1/2 plus y to the 1/2 over 2x to the 3x. Because I had kept fractions on the board.
No, can't be right. And also you should have minus.
Would there be a dy over dx in the...
Oh yes. Thank you. Good point. Okay. We'll blame this on It's too early in the day. And yeah, you might actually end up with what you're saying, but you should still have a minus. No, actually, maybe not. Okay, square root of y divided by 2 times the square root of x. Right? Now it looks better. So then we have square root of x divided by 2 times the square root of y times square root of y over the square root of x minus the square root of y over 2 times the square root of x divided by x, and it'll become a plus. So yeah, I think we're coming close to your answer. So I have square root of x plus the square root of y divided by 2 times x square root of x. So I guess you were correct. What?
That was horrible.
Why is it d squared y over dx squared?
That's the notation for y for the second derivative.
Oh.
Okay? Yes.
What is it?
26. So I would say, since these were part of your homework and I spent all this time solving them, they should really be
On the exam.
yeah. Veto? Sorry, it's not a democracy. You're writing? Alright, so what's the derivative on the left hand side? 4x cubed plus 4y cubed dy over dx is equal to? 0. Wonderful. So, on the same token as what we've done before, dy over dx is going to be minus x cubed over y cubed. The 4's cancel out. And so d squared y over dx squared is equal to minus 3x squared y cubed minus 3y squared x cubed dy over dx divided by y to the 6th.
I got a question about that. Isn't the x cubed negative on the right side? So,
Which right side? Over here?
like 3y cubed x cubed. Isn't the x cubed negative?
Here?
Yes.
Why would it be negative? Minus?
It's negative in
Minus. All I'm doing is I'm keeping the minus in front and I'm taking the derivative of the fraction. Yes?
I'm sorry, I just don't know where you're getting like all the numbers from and like the y.
Which part?
Like just the very last part.
Well, again, forget about the minus because that just comes in here. I have a ratio, which means I need to apply the quotient rule. The derivative of the top times the bottom minus the derivative of the bottom times the top.
Okay.
And maybe I should write it this way, since it seems to be confusion. Times dy over dx times x cubed. And the quantity in the parentheses is the derivative of y cubed. Does that make sense? Laws of exponents. A to the m all to the power n is equal to a to the m times n. Right? Okay, and this can be simplified as d squared y over dx squared is equal to, now dy over dx is just x minus x cubed over y cubed. So let's write it out. We have minus 3x squared y cubed plus 3y squared x cubed times x cubed over y cubed divided by y to the sixth.
Whoa, where did the plus come from?
Minus times minus. dy over dx is negative.
Oh yeah, that's right.
So in the second derivative,
Okay.
you put in the first derivative of dy dx.
And now d squared y over dx squared is equal to, let's see,
That's not
3x to the sixth minus 3x squared y to the fourth divided by y to the seventh.
You do dy dx.
I replaced it.
Use substitution.
I replaced it with what I knew it is equal to. You are supposed to do that.
So you always do that when you take a double derivative of
Well, just think about if I ask you for what's the second derivative of, I don't know, x squared plus y squared or whatever. I mean, x squared plus 5x or whatever it is. What do? You take the first derivative and then you take the second derivative and you end up with just a function of x, right? There's no, at no given point you actually have the derivative in there. And so the whole point is at the end, you should only have a function of x and y. Okay. Wow. That was half an hour worth of questions. Is this making sense? Kind of? Sort of? As I said, the next section is called related rates, and we're going to apply implicit differentiation to actually word problems.
word problems.
Yes, your favorite. Right? They're by far your favorite types of problems, right? Okay. Homework. It's okay. Thank you. Alrighty. So, as promised, we're gonna start talking about word problems. So the idea is, the whole idea behind related rates is, the key idea is that you have quantities that are related. So for example, I'm just going to read the first sentence here, just so you kind of get a feel for what we're talking about. If you pump air into a balloon, both the volume and the radius of the balloon are increasing as you pump the air, right? And as it turns out, the rates of increase are related to each other. And so the question is, sometimes it's a lot easier to actually figure out the rate in which the volume increases versus the rate in which the radius increases. And so this is basically more or less what we're going to be looking at. And I don't know, maybe I should skip, or I'll do one example so you can follow if you want through the book as why exactly I'm doing this, and then excuse me, we can just go directly to some problems and pick some problems up. So example 1 says the following: air is being pumped into a spherical balloon so that its volume increases at a rate of 100 centimeters cubed per second. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? So what happens about word problems is, and I was obviously being sarcastic when I said there are favorite types of problems. What you need to do about it is you need to basically read it maybe once, maybe twice, to understand exactly what's given and what's actually asked of you. So what I would suggest that you learn how to do, because this is the first time we actually are looking at word problems, right, in this class. I would say, let's read it together and actually gather information as we move along. So, air is being pumped in a spherical balloon. Okay, that's nothing's actually telling us. So that its volume increases at a rate of 100 centimeters cubed per second. So this is the first time we actually are given something. How should we write that out? So, rate of increase of volume is 100 centimeters cubed per second. Would you know how to say that in mathematical terms? Because obviously that's a bunch of words. dV over dt is equal to 100 centimeters cubed per second. Does that make sense? Remember what we defined derivatives to be. Instantaneous rate of change, right? So the rate of change of the volume means the rate of change of the volume, obviously with respect to time, is equal to 100 centimeters cubed per second. Does that make sense? Yes? Okay. The next sentence says, how fast is the radius of the balloon increasing when the diameter is 50 centimeters? So let's read this again. How fast is the radius of the balloon increasing? What is that actually saying? What it is actually asking us to find? The rate in which the radius changes. Does that make sense? Yes? When r is equal to 25. It says the diameter is equal to 50 centimeters, which means the radius is half of the diameter, right? Does this make sense? Okay, so how should we do? How should we solve this problem? We took the word problem and we expressed it in equations, right? That was the first step. Now the next step is to find the relationship between volume and radius. So, anybody remembers what the volume of a sphere is? Four-thirds pi r cubed. Yes? Now, the key idea is volume is a function of time, r is a function of time. So if I take derivatives in both sides with respect to time, what do I get on the left-hand side? dV over dt. What do I get on the right-hand side? 4/3 pi. And what's the derivative of r cubed? 3r squared dr over dt. Yes? So now the 3's cancel out, and I'm left with the dr over dt is equal to 1 over 4r squared dv over dt. Right? Pi. 4 pi r squared. And now r is 25, so dr over dt is going to be 100 divided by 4 pi times 25 squared, which is 100 over 25 times 4 is 100, times 25 gives you 2500 pi. And since this is a problem from the homework, from the examples, dr over dt is equal to, I guess they left it that way, 1 over 25 pi centimeters per second. Yes?
Okay, so I have a question. When you get dr dt by itself, you divide 4 pi r squared
Yes.
on the right side. How do you know that the left side is 1 rather than 0?
What do you mean? The left hand side is dv over dt.
I know.
So how can it be 0?
I don't know. I'm just curious. You're moving one part of the equation towards the other side.
If I write dr over dt is equal to dv over dt all divided by 4 pi r squared, is that better?
Yeah.
Does that make sense?
Okay.
Well, it's the same thing. Think about x over 2 is the same thing as 1/2 times x. I just wrote the constant in front of the derivative because the derivative was already a fraction, so yes.
How did you get from d over dt to dv over dt and dr dt?
I'm taking derivatives both sides with respect to time. Right? That notation says I'm taking derivatives with respect to time in both sides, with respect to t. That's what I've been writing on all these implicit differentiation problems. I'd always put a parenthesis and just say, take derivatives in both sides, so I'll just write d over dx. In this case, by the way, related rates, most of these problems are going to be related to time. Sometimes you're going to have something related to x, but anyway, does this make sense? In any shape or form? Okay, let's look at some more problems. Or let's actually look at some problems, since this was an example. Number 1, you want me to start off slowly?
Yes.
Okay, 1 on page 131. If V is the volume of a cube, so we have a cube of length x, so if V is the volume of a cube with edge length x and the cube expands as time passes, find dv over dt in terms of dx over dt. Does that make any sense?
No.
Again, you don't have to read the problem all at once and expect the answer to jump at you. That's what I was telling you about word problems. Just read one sentence at a time and figure out exactly what you're given. So first of all, if V is the volume of a cube with edge length x, can you tell me what V is?
X cubed.
V is equal to x cubed, right? Now it says the cube expands as time passes. What does that tell you about V and x?
They have a respect to
They're both functions of time, right? That means that V is in fact V of t and x is in fact x of t. Does that make sense? And you're asked to find dv over dt in terms of dx over dt. So what we've done so far, again, is just apply the derivative on both sides. What do we get on the left-hand side? dv over dt. And what do we get on the right-hand side? 3x squared dx over dt. And that's all we had to do.
Boy, we're taking the derivative of the volume. First step. And then when we take the derivative of the volume, we write down dx over dt right next to it, just like we did with the y.
You have to be careful for all of these related rates, and this is why I said you have to make sure you know how to take implicit differentiation or how to apply implicit differentiation. You have to keep track of what of your letters are in reality functions of time. Okay? Because I could have, instead of a cube, I could have a box that, let's say, it actually just the base changes but the height doesn't. And so when you take derivatives, the height is just going to be, the derivative of that is just going to be 0 because it doesn't change with time. So the key idea is, it's not that you're just writing dx over dt here because, well, you know, that's what you did in the previous section. The key idea is what I just wrote here. V and x are both assumed functions of time. Which means when you take the derivative of v, there should be a dv over dt. When you take the derivative of x, there should be a dx over dt. Does that make sense? Yes?
So just to clarify that, both the volume and the length are changing?
Yeah, they said the cube expands as time passes. So if it expands, it means the sides expand, also the volume expands, right? It's basically just, you know, getting bigger. And so that's why we have that.
Yeah, and so if both are changing, there's going to be...
They're both functions of time then, because they're changing with respect to time.
slope with the tangent. So there's going to be tangents or derivatives for both of them?
Yes.
So you need
Yes. This is the first time, by the way, after we talked about implicit differentiation, which helps us take these derivatives. This is the first time we're actually looking at derivatives more as related rates, or sorry, instantaneous rates of change versus slopes of tangent lines. This is the first time we're actually looking at them a lot more as the instantaneous rate of change versus actually a slope of a function. Okay? And remember, I told you when we looked at derivatives, there's different ways of defining derivatives, and they're all actually quite different. Okay, number 3. How slow should I go with this, by the way? You want me to skip number 3? 3 on page 1-3. Was that good? EACHSIDE of a square is increasing at a rate of 6 centimeters per second. At what rate is the area of the square increasing when the area of the square is 16 centimeters squared? Okay? So this is what I would like you to do. As I said in the first part, the first example that I put on the board, I would like you to read the problem so you kind of get familiarized with what is actually asked of you. Second of all, let's take sentence by sentence, or not even sentence by sentence, but like phrase by phrase, and actually put it in mathematical context. So the first set says each side of a square is increasing at a rate of 6 centimeters per second. Now, this problem doesn't require it, okay? But later on, it's going to be much more beneficial if we actually draw a picture. So, let's start off with a picture. That's a square. It has both sides x. I'm claiming it's a square. Okay. So now let's look at it again. Each side of a square is increasing at a rate of 6 centimeters per second. What does that mean in terms of mathematics? Each side of a square is increasing at a rate. Increasing rate. That should come to you as the rate in which x increases is equal to 6 centimeters per second. Okay? There's two things here that you have to keep track of. The rate is increasing, which means, and we'll see this later on in different problems, this is positive. If you would have said it's decreasing at a rate of 6 centimeters per second, then dx over dt would be minus 6 centimeters per second. Does that make sense? Okay, next statement. At what rate is the area of the square increasing? So, what are we looking for? dA over dt. Does that make sense? Yes? Okay. When the area of the square is 16 centimeters squared. So when A is equal to 16 centimeters squared. Okay? So now we basically finished off everything that we were given, right? What do we need? A way to connect A with X, right? And we know it's a square, so A is equal to X squared, right? Yes? Area of a square? So now, what do we do next? So, dA over dt is equal to 2x dx over dt. Right? Yes? Okay. What is the next step? 16 where? dx dt is equal to 6. What is x equal to? What is x when a is equal to 16? Well, 16 is equal to x squared, and that means x equals to 4, right?
That's our answer.
That's just x. dA over dt then is equal to 2 times 4 times 6, which gives us 48 centimeters squared per second.
So we just trying to get all the variables to get.
You're trying to get a number, yes.
Do as much touch as we possibly can.
Yes. Okay. Should I do 5 or 7? It says if. Which one, 5 or 7? Okay, so if z squared is equal to x squared plus y squared, dx over dt is equal to 2, dy over dt is equal to 3, find dz over dt when x is equal to 5 and y is equal to 12. So, you tell me what it is. What should be the first step we want to do? Okay, take a derivative with respect to time. What do you get? What do you get?
2z dt over dt.
Okay, work it out. Tell me what dz over dt is.
2z.
I'll tell you what it is if you want. It's 46 over 13. Do you want me to actually work it out?
Yes, please.
The whole point was you try it out. So first step, we take derivatives in both sides with respect to time. What do we get? 2z dz dt equals 2x dx dt plus 2y dy dt. Right?
Is that d to over dt?
Sorry?
Is that when you take the
Yeah, basically. Okay, now first step, notice that I can divide by 2 both sides. Right? So I won't have any 2's anymore. Now, what do I know? What am I trying to get at? I'm trying to get at what dz over dt is, right? I know what x is. I know what dx over dt is. I know what y is. I know what dy over dt is. I don't know what z is. Yes. So plugging in x and y in the top gives you that z is equal to 13.
Oh.
They're Pythagorean numbers.
Oh,
5, 12, and 13, yes.
so we just plug in 5 for x and y for 13, but then doesn't dx over dt equal...
Yes, but all I've accomplished here is compute what z is. What is the problem actually asking? dz over dt. So, as I said, dz over dt, or 13 times dz over dt is equal to 5 times 2 plus 12 times 3. And so dz over dt ends up being 46 over 13, as promised. Okay, ready for stuff more complicated?
It's complicated.
Oh no, it's going to get much more complicated.
See, you figure out what
It's gonna use the chain rule.
Yeah, I don't know if we end up with that. By the way, your homework, one of the problems in your homework is number 16. And, you know, I guess the Rockies are out of playoff, but if you're actually still following baseball, you can solve this problem and really answer your curiosity when you watch baseball next time. It says a baseball diamond is a square with a side of 90 feet. A batter hits the ball and runs towards first base with a speed of 24 feet per second. At what rate is his distance from second base decreasing when he's halfway to first base?
Oh my god.
As I said, you'll watch baseball differently next time when you watch it. Well, you gotta know, if you have enough time to throw him out or not. I mean, it's vital.
How did, on that problem, how did you do z equal 13?
Well, you can just plug them in. 5 squared plus 12 squared is 169. Square root of that is 13. I was saying 5, 12, and 13 are Pythagorean numbers. So when I saw 5 and 12, I knew 13 is z is 13. Since I said it already twice now, do you know what Pythagorean numbers are?
Yes. 3, 4, 5, 12.
Okay. Let's do 11. Okay. I'm going to read it first. We'll gather some information and then we'll try and actually write out mathematically what we're looking at. A plane flying horizontally at an altitude of 1 mile and a speed of 500 miles per hour passes directly over a radar station. Find the rate at which the distance from the plane to the station is increasing when it is 2 miles away from the station. So, what do we know? Well, we have this lovely radar station. And then we have this lovely plane. Let's see.
Yes.
Flying, right?
That's actually pretty good.
Okay. What else do we know?
Okay, it's 1 mile above.
We know the height is 1 mile, right? That's good. What else do we know?
The rate of flight.
Okay. This is the first time, as I said, things are getting a little more complicated because we're not actually given variables. Okay? So, what is the problem asking us? Or what don't we actually know? So, we have a triangle. If I name this x, if I name this y, what do I know about x? What do I know about y? Do I know what dx over dt is? So, let's do this. That's fine. So what is dx over dt? 500 miles per hour. Does that make sense? What is dy over dt? That's what we're trying to find out, right? The problem asks to find the rate at which the distance from the plane to the station is increasing. Right? What else do we know? The plane is 2 miles away from the station. So y is equal to 2. Right? 2 miles? Okay. Is everybody understanding how I got all of it? Okay?
They took the distance in a straight line from the radar station to the plane, not like around.
No, it's the actual distance from the radar to the plane.
Right, so the dx represents how fast the plane's going. The dt represents the time, and the dy represents...
No. I mean, yes, technically. I told you, I said that when you're dealing with these types of fractions, this is not an actual fraction. This is a notation. It just says the rate of change of y with respect to time. The rate of change of x with respect to time is the speed of the plane. Does that make sense? The plane is moving on a straight line, horizontal straight line, right? Yes?
Yes.
Okay. What next?
Relate y of x.
Well, we need to figure out a relationship between y and x, right? And the relationship comes from the Pythagorean theorem that says y squared is equal to 1 plus x squared. Right? That's a 90-degree angle. Right? Okay. What else do we know? Or what should we do next?
Don't we already know y?
Sorry?
Don't we already know y?
Y is fixed or only at a one particular time. We're asked to find the rate of change of y when y is equal to 2. The plane is moving, it's not fixed. Okay? Which means y will change with respect to time. So y is equal to 2 is just one at one particular moment of time, and it's not always. So the thing that you should never do is actually put in 2 for y right now. What you want is you want the rate of change of time with respect to time. So we end up with 2y dy over dt is equal to 2x dx over dt. So far so good? And we need to find dy over dt, so it'll just be x over y times dx over dt. Right? And now what's next? Plug in everything we know, right? Well, we know y, we know dx over dt, we don't know x. How do we find x?
Plug in 500. The dx over dt.
4 is equal to 1 plus x squared. So x squared is equal to 3. So x is equal to the square root of 3.
Oh,
Yes? Well, the only reason we're doing that is to find x. What I was saying not to do is, what I'm trying to avoid people doing, and I'm saying this because I've seen this many times as an error, is students have a tendency to put in 2 in here and then take derivatives. And if you do that, the derivative of 4 is just 0, which means you're really losing a lot of the information. You're actually never going to actually come up with dy over dt because there's no y to speak of anymore. Is this making sense? So the answer will be dy over dt then is equal to square root of 3 divided by 2 times 500 miles. Yes? I'm sorry, say that again?
How do you figure out the units and keep those?
Miles per hour. I still didn't catch. How do you figure out?
The units?
Oh, the units. You can actually just write them out. Like, if you ever took a physics course, you were taught to actually just write out all the units, right? And it'll come out to the right thing. Well, think about this. dx over dt. So, dy over dt is x over y times dx over dt, right? X is miles, divided by y is miles, and dx over dt is miles per hour. They all cancel out and you end up with miles per hour. Does that make sense? Okay. Semi-hard or harder? Harder?
Semi-harder.
13? Okay. My choices were 13 or 15. Okay, 2 cars start moving from the same point. One travels south at 60 miles per hour, and the other travels west at 25 miles per hour. At what rate is the distance between the cars increasing 2 hours later? So now that we read it, our next step should be to actually draw a diagram to illustrate what we actually just looked at. So it says 2 cars start moving from the same point, right? So that would be my point. They both start moving from that point. One car travels south at 60 miles per hour. So my car is going south. The other car is traveling west at 25 miles per hour. So the other one is going west. If this is x, and this is y, and this is z, what do we know about what?
What do we know about what?
So x is first car. No, this is second car, right? Because the first car went south. Second car. y is the first car, or I'm going to put quotation marks since I'm really not being very accurate with that. What I mean about x and y is actually the distance that the car traveled after, a certain amount of time. So what do we know going back to the problem? One travels south at 60 miles per hour. What does that mean as far as my diagram over here? dy over dt is equal to 60 miles per hour. Right? Also, dx over dt is equal to 25 miles per hour. At what rate will the distance, or what rate is the distance between the cars increasing 2 hours later? So, what is dz over dt after 2 hours? Right? What next? We need to relate x, y, and z. How do we relate them? Pythagorean theorem says z squared is equal to x squared plus y squared. Right? What next? 2z dz over dt equals 2x dx over dt plus 2y dy over dt. Divide by 2 both sides. dz over dt is equal to 1 over z times x dx over dt plus y dy over dt. Right? Okay, so now let's put in what we know. What do we know? We know dx over dt, we know dy over dt. Can you tell me what x is?
Two.
50. Very good. Why 50? Exactly. The rate in which x changes is 25 miles per hour. After 2 hours, x is 25 times 2, which is 50. Does that make sense? So 2 times 25, which is equal to 50. Y is equal to 2 times 60, which is equal to 120. Can you tell me what z is? $130? 5, 12, 13, again, the same Pythagorean numbers. The fact that it's 50 to 120, 130 doesn't really change anything, right? So, dz over dt then becomes 1 over 130 multiplied by 50 times 25 plus 120 times 60. Bless you. So it's what is it? 7,200. 8450 over 130. So 845 over 13. Which equals 65, I think, right? Miles per hour. Does this make sense? Yes? How about we set up 19? I'm not necessarily going to have time to solve it, but I would like at least to set it up so you can see what we're looking at. At noon, ship A is 100 kilometers west of ship B. So ship A is sailing south at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? So, let's read the problem again and see what we're actually looking at. First things first, at noon, ship A is 100 kilometers west of ship B. So if this is A, then this is B, and this is 100 kilometers, right? Does that make sense? Okay, the next thing says ship A is sailing south at 35 kilometers per hour. Right? It's going down. Let's name this x. And let's come back here and say that dx over dt is equal to 35 kilometers per hour. Ship B is sailing north at 25 kilometers per hour. So if we call this y, then dy over dt is equal to 25 kilometers per hour. How fast is the distance between the ships changing? So if I call this z, the question is